Hi everyone, I'd like to solve and explain problem number 6.1 in Renewable and Efficient Electric Power System book. First, let us read the question. Horizontal axis wind turbine with a rotor 20 meters in diameter is 30% efficient in wind speed 10 meter per second at 1 atmosphere of pressure and 15 degrees Celsius. A. How much power would it produce in those winds? B. Estimate the air density on 2500 meter mountaintop at 10 degrees Celsius. C. Estimate the power the turbine would produce on that mountain with the same wind speed, assuming its efficiency is not affected by air density. First, let us explain let us see what is the given. Here we got the diameter, which is 20 meters, and the efficiency, which is 30%, and the velocity or the wind speed is 10 meter per second. And the area, we have to calculate the area by the pi multiplied by diameter squared divided by 4, which gives us 314.16 meters squared. And the rho, which is 1.225 kilogram per meter cubed at 15 degrees Celsius. So first we want to solve the power would it produce in those winds. A, we will solve it with this method or this formula. P, wind at the wind, equal half the rho, we got it from the given, 1 multiplied by 1.225 multiplied by the area, which is 314.16 multiplied by the wind speed, which is 10 cubed, multiplied by the efficiency, which is 30%, so it's 0.3. The P will give us 57.726 kilowatts. This will be the answer for A. And B, the air density, estimate the air density on a 2500 meter mountain top at 10 degrees Celsius. So in this table, we will recognize that in the 10 degree, we will get a 1.02 density ratio and 1.247 the density. So here the KT is given, which is the density ratio is 1.02. The K, we will use this formula, but the Ka is not given, so we have to find Ka, which is the pressure ratio. So the pressure ratio equal the pressure. So in this table here, the pressure equal the pressure ratio. Okay, so it's 1 here and 1 here, 0.977 and 0.977 also here. So here I'm solving it. The pressure equal the pressure initial, which is 1, and exponential minus 1.185 multiplied by 10 powered of minus 4 multiplied by the height, and which is here 2500 meter. So the initial here is 1 atmosphere equal 0.74. 0.74, this is the ATM, the atmosphere. And we, as we said, the pressure equal the pressure ratio, which is the Ka. So the Ka equal 0.74. So here, as we mentioned, you want the air density. The air density equal 1.225 multiplied by kT multiplied by Ka. So the rho equal 1.225 multiplied by 1.02 multiplied by 0.74 equal 0.92 kilogram per meter cubed. Here we got question B. Question C, estimate the power the turbine would produce on that mountain with the same wind speed, assuming its efficiency is not affected by air density. So we got the rho 0.92. So we got the P at 2500 meter equal 57.726, which is the P initial, the power initial at 15 Celsius, multiplied by 0.92, which is the rho in the 2500 meter, and divided by 1.225, which is in the 15 degrees Celsius, will give us 43.35 kilowatt. So we see here that the power and the density and the air density is a proportional relate, and as we here see that the density and the temperature is an inverse relation, as also the pressure and the altitude by meters is also an inverse related. So when we here, for example, we got the rho here at 15. So the rho, how we calculate the rho at 15 degrees Celsius, we will have 1.225, which is here the formula for the rho, which is the air density. The kT, as we see here, the kT is equal 1. So 1.225 multiplied by 1, which is the kT, multiplied by 1 here, because why 1? Because the density of the dry air at pressure of 1 atmosphere. So it will be 1. The Ka as the pressure ratio will be 1. So equal 1.225 kilogram per meter cubed. And thank you for watching.